We're both Stefan Esser.
And we're here to teach you PHP 101. So,
well, we already said the main thing, right? So all you really need to know about PHP is that it sucks and you shouldn't use it. So, I mean, I can't see having a 75-minute talk that goes beyond that. So you could have walked into the room, it sucks, and you leave. So this, you really know who your friends are when, you know, you're talking, everybody's like, hey man, it's great to see you, I haven't seen you in a long time, I'm really looking forward to your talk. And they say, what time is it? Oh, it's like 10 a.m. And they're like, oh, screw that, I'm not getting out of bed. So that's kind of how it is today. I think our proctor actually took a dive and slept in late on purpose so they didn't have to pronounce his name. But I am Nathan Hamiel. I am a, yes, it's pronounced Hamiel. I'm a principal consultant on FishNet's application security team. I'm also a professor at the University of Advancing Technology. That's how I met this guy originally. And
my name is Marcin Wielgoszewski. I work for Gotham Digital Science as a security engineer. So kind of the goal or theme of our talk is that you can't just rely on your standard toolkits anymore. You know, there's many more people testing web applications than have ever been testing before. A lot of these people are coming from backgrounds that aren't development. A lot of them have been managing firewalls and everything else, and they haven't really gotten down to understand these problems. So it's really up to the person doing the testing to ensure that you have proper coverage, that all of your bases are covered. There's also difficult cases too, where standard toolkits fall flat on their face, or they're, you know, don't have any visibility into what the application is doing. So you have APIs and specialized data formats and protocols that your standard vulnerability scanners just don't understand. You also have things like sequenced operations and randomized data. So if you can't replay an attack, if a tool can't replay an attack, which is about how a vast majority of tools work, then you're not going to find the vulnerabilities. So basically, we want to have an intervention. We want to have an AppSec intervention. So the people who are out there that are just getting into AppSec, they need to learn at least what object-oriented programming is. So building block. And then one more slide here. So this is kind of a modern infrastructure slide. And if you look, we have our rich contents, we have our web front ends and back ends, and we have APIs and fat client apps and everything else. Well, if you think about like how deep your web scanner is going, it's not even hitting, you know, all of the front end potentially. Like your web scanner that you're using might not even understand anything that the Flash is doing. So in that case, you're really not hitting the big picture. And the theme of our talk is that at some point you're going to have to write your own test cases and clients. And that's what we're advocating, and I don't think anybody's really disagreed with us. I mean, even scanning vendors aren't going to tell you that their products are 100% effective at finding vulnerabilities. So why we choose Python? I like it because I could rapidly develop various test cases and tools. You know, you can whip up something in like 30 minutes that does some really cool stuff. It's really easy to understand, so especially when you're like looking at other people's code, real simple. I like the white space. Some people are Nazi about it. I like it. So.
And there's plenty of help and support available in the language as well. Like, so show of hands, who here has ever written anything in Python, even if it's like Hello World? So just about everybody. Well, that's good. How many people here have ever written anything in Perl? So how many people in here wanted to punch themselves in the face after writing something in Perl? That should be just about everybody. If you enjoy using CPAN, then you are a sadist. Nobody likes CPAN, and they still use CPAN. It's crazy to me. I mean, even, you know, Ruby has gems, Python has the easy install dist tools, so it's time to move on to a better language.
So there's tons of tools out there already written in Python. Some of the big ones you probably are familiar with, like Peach, W3AF, web scanner written in Python. Those of you guys coming from like the network side of things probably are familiar with Scapy, which is an awesome library that's like showcase of like Python and security and network type tools. Those of you coming from like reverse engineering side, if you use IDA, there's like IDA Python, there's PyDBG, in PyMay, stuff like that. It's just awesome.
So you might be wondering, you've heard us talk that there's problems with modern testing tools. So you might be wondering where Python would fit into your testing strategy. And it fits right at the point where you're verifying vulnerabilities, the things that are faster to do, like scripted together than you could do manually. Because it's feasible to go through the website and test every single input by hand. Now, I don't know why you'd want to do that. It doesn't seem very effective. And if you're like a consultant, you'd probably lose your job, right? Because it would take like 6 months to test a single app that you could have tested in a week or 2 weeks. So that's where Python fits, right there in between your manual analysis tools and your fully automated scanning stuff. There's a couple different Python implementations. We just highlighted like 3 major ones. CPython is the main version of Python that you probably think of. It's written in C, it's fast. Jython has been around for a long time too. That's actually Python inside of Java. And on the flip side, IronPython is Python inside of .NET. Other than just having an excuse to put Ron Jeremy in our slides, this is about whatever language you choose. Like say, I don't know why, if you weren't interested in Python, first of all, I don't know why you would be here, but if you decided to use something else, you want to make sure that the capabilities of the language match with what you're trying to do. You need to be able to speak the language of the application. So if your app needs to understand like SOAP, then you need to have something that can construct SOAP. So whatever data formats, whatever languages, it needs to speak. If it needs to speak HTTP or some other binary protocol, you need to make sure your language can speak that, and that's what this is about.
So some of the modules you'll run into, constructing clients, and writing Python tools, there's HTTP lib and URL lib. Those are probably the most common ones you're going to run into using. Some of the third-party ones that you might not know of that are real useful is things like HTTP lib 2 and URL lib 3. Excellent parsing library out there is LXML, as well as there's some other things for other formats. So.
And what we're distributing here, and it's actually available for download right now. I know it was kind of dumb not to show you the URL for it, but along with this talk, we have a zip file that contains all the tools that we're releasing today, and just example code snippets that you can go and like refer to for different things. So that'll be in the zip file. We're not going to spend a lot of time talking about that. The only thing I'll mention about URL lib 2, the important thing is that it's extensible. So you can extend it to add new protocols as they come along. You might be wondering, too, when you start constructing, especially if you start learning a new language or whatever, if you start constructing your clients, you're making changes to headers, you're making changes to content, you might want to see what the server would see. So I wrote this little tool called reflect request, and it's in the zip file. And all it does is any get, post, put, or delete you send to it, it echoes it directly back to you. And when I was writing Monkey Fist for last year's Blackhat, I needed a way to see if the CSRF attacks I was generating, like what the server saw. So I ended up writing it there.
It's basically just trace in Python, 4 lines.
So data representations. Anybody who's ever done any web testing knows about encoding in different formats and data representations. Sometimes browsers like IE understand different encoded formats versus Firefox. So Python has string methods just like any other object-oriented language. So every string in Python is an object. One of the features you can do is .encode. So if you did like string .encode, base64 or hex or rot13 even. I know rot13 sounds kind of funny and we all get a chuckle out of it, but just 2 months ago, we were doing an assessment on an application that was trying to obfuscate URL paths using rot13. And it was painfully obvious because you'd see like dot, or colon, / a bunch of weird characters, and so it was pretty obvious. Dharma encoder is a tool I wrote because I like having a standalone encoder, and I like also wrapping values in text. So the magic of Dharma encoder is in the encoder lib, and so if you wanted to know in Python how to represent data a certain way, like there's SQL character encoding and Oracle encoding and a bunch of other things in there. You can just look through the encoder lib on the Google Code site and see that all you want. So screenshot. This is basically what it looks like. It's a PyQt app, and you can have a drop down, change different things, and you can also wrap it in like script tags. I guarantee that there's bugs in this because I wrote it. So please tell me if something's broken or something, you want something in it, and we're not going to spend too much time on that.
All right, so when you actually get responses from the server, the most common formats you're going to run into is like HTML, XML, or JSON. The library that you want to use when parsing HTML or XML is LXML. The nice thing about it is, like when you run across like malformed HTML, lots of parsers out there will break as soon as it detects invalid markup. Whereas LXML will actually handle the invalid markup for you. And you may be familiar with like other modules like Beautiful Soup or HTML parser or a couple others. Reason why we don't recommend you guys use these is because they're not as fault tolerant as LXML. They're actually written in Python, whereas LXML is written in C. LXML is a lot faster when it comes to parsing content. And the author of Beautiful Soup expressed not wanting to continue supporting Beautiful Soup. So he kind of recommends everyone actually use LXML instead. It's actually a nice library for XML parsing. And the other library for parsing things like JSON is actually JSON.
Yeah, and everybody in here knows that the web is like broken just a touch, right? So like if you go run Python's HTML parser over the top of it, it's going to break horribly.
So just parsing some simple HTML content like that we get from a server. Say we want to iterate over every link in the document. We just iterate over every A tag and just get the href attribute from it. It's simple as this. It's like literally 3 lines of code. We're done. Some other use cases I find XML parsing really useful, especially when I'm doing like code reviews and code review assisted black box testing. Is like parsing out web XML files. So getting like the servlet names, servlet classes, and the URL patterns that they map to, so that like I could just dump it out into like some Excel spreadsheet, and as I'm like testing, I like mark down what I tested, what I haven't. So this is an example that just uses XPath expressions to get the actual values of the elements in the web XML file. So it's relatively simple.
JSON is kind of interesting because JSON actually maps almost directly to Python types. So a JSON object is basically a Python dictionary, and a JSON array is basically a Python list. So it matches up pretty well. So in a couple lines of code, you can go ahead and rip things out of JSON. This is an example code for just hitting the Twitter API and pulling all the current trends. I guarantee if you run that code right now, this talk is probably not one of the top trends on Twitter. It's probably like Britney Spears again for some reason. I know Britney Spears like is 1995 or something. So for fuzz cases, one of the most common things you're probably going to want to do is web fuzzing. But rather than just taking this brute force approach and just ripping through the app, you want to do some intelligence on it. You want to make sure you understand what protocols it's speaking, because one, you're probably going to want to violate them, and two, you're probably going to want to stay within the protocol when you're doing other types of testing. So you want to know your parameters, you want to know what data that it accepts, and really do your homework on it.
So one of the things I run into with scanners, a lot of them try to throw everything at once at the application, like fuzzing every single request. The downside to that